All right, everyone, welcome. Anyone that's joining us, we'll give it a couple minutes just to let everybody pile in. Very excited about today's session. I'll do a quick intro. My name is Daniel Warlow. I work for Campari. I'm the Italian portfolio ambassador. I cover all things bitter, Amari, and Digestivi Aperitivi for our portfolio. Today is a very special day for us. It is National Artichoke Day, so we are very excited. Obviously, the one brand that is always talked about with artichokes and bitter things is Cynar. It's been around since 1952, so it's a bit of a yearly anniversary. Even though we don't know the exact birth date, I guess today would be our birthday, I guess, in a way, which is really exciting. So please celebrate with us today with some Cynar if you have it. I'm very, very excited about this session. This is... I almost feel like it's the culmination of everything that I talk about, but in a way more scientific, way more official way from other people. So I'm learning just as much as everybody else. And this is really, really exciting for me. So today we have actually 3 panelists, which is awesome. These 3 panelists also have a book that I would like to promote as much as possible during the session. After the session, we'd love to get it into everybody's hands, if that's all right. The book itself is called Botany at the Bar. Thank you very much, Selena, holding it up. Botany at the Bar, The Art and Science of Making Bitters. I am joined by Selena Ahmed. She has the book in her hand. Ashley Duvall and Rachel Meyer. So, ladies, thank you so much for not only the work that you've put in on this session, but the book, and for joining us and for your time. I'm going to sit back. I got my notes. I'm ready to take notes and learn. So please take it away. Thank you so much.
Thanks for the intro, and happy Artichoke Day.
Yeah, how's it going, everyone? Thanks for being here. This is Botany at the Bar, it's Science of Bitter. So Selena, Ashley, and I are going to take you on an interactive journey through the basis of bitterness and why we enjoy it so much in our drinks, and why it's so important to be able to promote and spread the love of bitter. So we're a team that we call Shoots and Roots Bitters. We all met when we were in graduate school at the New York. We were all working at the New York Botanical Gardens, studying different plants. I was working on eggplant, Selena was working on tea, and Ashley at the time was working on acai. And all of us have studied different crops since then, and have branched out and moved around, and now all have jobs in academia. And we teach, we do research, we work on crop breeding, we do a lot of science outreach. Selena has a really nice book called Tea Horse Road. I run a citizen science program where we sequence the DNA in soil called Cali DNA. And Ashley, you will find often walking around with a pocket trumpet. That's her on Letterman. So we all have, lives that are not just in the lab. And part of what we're excited about is using the bar, using working with bartenders and people that are making really awesome spirits to promote plant diversity and help conserve plant diversity. Because we recognize, like, not to be a downer on this, but we are in the Anthropocene where there's mass extinction happening, and people that are promoting a cocktail or Campari or something like that has a blend of different plants helps people care about plants. And you realize that you're on the front lines of conservation. So we tried to, when we were doing when we were in New York together, we tried to make lots of bitters that would help people appreciate more botanical diversity. So we had 9 lines of bitters that had over 200 species in them. Eventually, we put all of those recipes into a book called Botany at the Bar. But now what we're doing is we're actually designing a lot of blend compositions that are focused on biogeography, evolution, and ethnobotany. And in the future, we're hoping to launch some new elixirs that are based on orchards or ecological systems, especially with the pandemic, just getting people to travel with more beverages as their experience to sort of get to a new place is really exciting. And one of the things I really like about some of the products that we're able to talk about today, like Braulio, for example, so some of the Campari line, it is that they are place-based and they are completely reflecting an ecosystem of plants that interact with each other and have properties that help them live in a certain place. And those properties also help us for the same reasons as they help the plants. And so it's really neat when you think of this as a true community of different interacting species. So let's go to the next slide.
Thank you, Rachel. I'm now going to give a brief definition of what bitters are. So this is actually one of the questions we get asked the most in terms of bitters is what they are. People have different definitions, and we take this really all-inclusive definition of what bitters are. And this very much draws on our own field work around the world, working in different communities, rural communities, forest-dwelling communities, where we've seen people extracting botanicals from their surroundings in different types of solvents, whether this is a rice wine or whether this is another type of grain alcohol or a mead, as well as water, extracting these botanicals for these essential flavor compounds and these medicinal properties. And so based on those experiences of our own field work around the world, we've come up with a really broad definition of what bitters are. And that is they're essentially infusions or extracts of plants that are pulling out these flavor properties and these medicinal attributes into a liquid. So this liquid could be a fermented alcohol base, as I mentioned, a type of grain alcohol, or it could be a non-alcoholic liquid, including water. So you see this in the case of teas and tisanes, and also fats and vinegars could be used for this process. And so a really broad definition of what bitters are. And so if you're thinking about, I'm extracting coffee in water, is that a bitters? In the broadest sense, yes, you're essentially making bitters. So not just things that we see at the bar. And why have people been making bitters? And this is really to pull out those medicinal and flavor attributes, but also to preserve these sensory attributes so they don't go stale. And so people really have been kind of concentrating those attributes and having them have an extended shelf life beyond when those plants can be harvested. Next slide. And so the history of bitters in different cultures and communities around the world extends to thousands of years. People have been taking these plants from their surroundings for different well-being properties. And so there's all sorts of archaeological evidence, such as this image over here, where scientists have found remnants of fermented alcohol bases, such as mead, infused with all sorts of diverse plants. And so, for example, in ancient Egypt, a lot of tombs have been shown to have meads that were fermented with chrysanthemums and wormwood species, and a whole range of other tree resins as well. And so we'll talk a little bit further about where actually the different plant parts are, where we actually get these bitter compounds. And so historically, the use of these different bitters were for medicinal properties, and then eventually they've evolved to how we know them best now, which is as ingredients in our cocktails. Rachel. Mute.
Classic error. So Daniel, you are our official Campari rep joining us today. And I'm putting you on the spot. Do you know what this animal is?
It looks like a marmot.
It's not quite. Just one more time. Have you ever been to South Africa?
I haven't, no.
This is a rock hyrax. It's a close relative of the elephant.
Oh, yeah, they look very similar. I see the similarity.
Right? Maybe they have a bigger nose than a marmot by a little bit.
Yeah,
These are some of our oldest sources of bitters, and I just couldn't risk losing the opportunity to explain this to people, because when else do I get to talk about rock hyraxes? In South Africa, they're often referred to as dussies. Everyone will say, "Dussie piss, dussie piss." It sticks to everything. So a dussie will often eat medicinal herbs in the Mediterranean ecosystem. South Africa is one of 5, right? So California, well, okay, we won't list them right now, but a dussie will eat all of these medicinal plants, and then it urinates this extremely potent urine onto the same rock over and over and over again, where it makes like fossilized urine that you can actually scrape up and eat if you need a dose of medicinal plants. And so this was perhaps one of the earliest sources of a bitters. So if you were a little bit sick, maybe you got like a parasite or you had some sort of problem 50,000 years ago, you would eat this dusty piss that's fossilized. And if that didn't work, you just killed and ate the whole dusty.
I'm going to suggest this to the innovation team. That could be a new thing. That could be.
I've tried it. It's gross. So let's think of bitters in a more delicious sense. I'll bring it back to Selena.
Yeah, Rachel, that is fascinating. So communities still have that practice to this day?
Mm-hmm.
That is really fascinating. Yeah, so people have been making bitters, sort of as Rachel highlighted, for all sorts of medicinal uses. Some of the most prevalent uses for bitters making has been to aid in digestion, boosting immunity, strengthening the body for different types of energy, and preventing a whole range of disease. So there's also a lot of scientific evidence that has been looking at the efficacy of these different botanicals. However, less than 20% of the botanicals that are used in bitters have actually been examined for their efficacy in a clinical setting. And also the results and the evidence of this are very mixed. And so this is really one reason why we focus very much on the flavor attributes of bitters and really celebrate the deliciousness we get from these different compounds, especially the bitter compounds, which are one of our favorite tastes.
Selena, I wanted to actually pause right here and discuss like how often we should be thinking of using bitters. It seems like when we're going through some of like our ancient literature review, that a lot of the really prized herbals are things that you shouldn't necessarily take every day, or that you should take intermittently and switch up. So it kind of almost lends itself really well to cocktails, and maybe that's part of why there's so much diversity in bitters. Ashley, I wonder if you're thinking about this as well, where you might have a whole bunch of things on the shelf. And so as long as you're switching them up, you're continuing to get the functional benefits of those, because if you were to take them every day, it wouldn't necessarily be, you wouldn't necessarily gain all the benefits.
Good point, Rachel. I think it lends itself well to this collector mentality people have around bitters too, where you just can't have enough. I mean, we've seen collector shops where they are just lined floor to ceiling with every single type of bitters they can get their hands on. And some cocktail recipes call for a certain one, and everybody has a few of the staples on their shelves. But I think the diversity of them and the ability to kind of mix them up complements that sort of functional diversity aspect that you talk about well.
Yeah, and that really loops in really nicely with thinking sort of about dietary diversity. And so we've had this like huge reduction in the diversity of types of foods and beverages that we're consuming. And I think bitters really are an opportunity to bring that diversity back into our diets, back into our palates. We don't really know all the different phytochemicals and secondary metabolites, these compounds in botanical products that we need. And really bringing that diversity back into our diets can be really beneficial for supporting our diets, but also in supporting biodiversity. So that's what it makes me think about. Next slide. So where do these bitter flavors actually come from? Where do the medicinal attributes that we've been talking about come from? And so this is from the phytochemicals that are in plants. These phytochemicals are also known as secondary metabolites. And there's a huge range and diversity of these compounds. There's actually thousands of these different types of compounds that are found in plants. And some of the major classes of these compounds are the phenolics, which are found in a lot of fruits and vegetables, alkaloids, very bitter compounds, terpenoids, these are the more like piney, woodsy compounds, and isoflavones. And terpenoids are the ones that really tend to bring a lot of aroma to our beverages. And so understanding these compounds is important, because when we're creating bitters, what we're essentially doing is we're extracting or pulling out these phytochemicals from the plant material into whatever our solvent is. So it is really important to have an understanding of what the phytochemicals or secondary metabolites are in the botanicals that we're working with, so we can pull out the compounds that we want and sort of have efficient extraction. Next slide. And so ultimately, these phytochemicals that I just mentioned, these major classes, phenolics, alkaloids, different types of terpenes, influence our sensory attributes. So this is not just the aroma and taste, which makes up flavor, but also the visual attributes of botanicals, and they also influence the shelf life, and as we've been talking about, the health attributes. And so essentially, as humans, we're able to perceive the bitter compounds through this diverse range of taste receptors. We have about 25 different taste receptors, and Rachel, you can talk more about this because I know you've been digging through the latest scientific evidence, but we have these different taste receptors that are on our taste buds, and this is on our tongues, and this is where bitter taste perception is initiated. But we also have these bitter taste receptors in other parts of our bodies, including our gut and our pancreas. Rachel.
Okay, next slide. Selena, this is actually you, and I'm going to shut my dog up right now.
Got it. Right. So when we're thinking about those different taste compounds, those different phytochemicals, let's take a botanical that we commonly use, let's say sweet orange. And what are the different compounds that are in here that are imparting flavor? So this is just an example. Some of the sensory attributes that we get from sweet orange. It has a bunch of terpenoid compounds that give it a whole range of flavors, including herbaceous, sweet, and refreshing odor, a spicy bergamot flavor with these really piney notes. Sweet orange also has this beta-mycin compound, which has a spicy and woody note. It also has really a whole range of other aromatic compounds. In fact, there have been over 100 different secondary metabolite or phytochemicals found in sweet orange. And so the flavors that we're actually perceiving is really a synergy, not just of one compound, but of these multiple compounds interacting with each other. And so exploring the phytochemistry of botanicals is really fascinating because of the way these different phytochemicals are dancing and interplaying with each other. Next slide.
So I'll bet not too many of you think about thistles and dream up the next culinary recipe to dazzle your dinner party guests with. So it's worth noting that there's really only one thistle that we eat, and that would be the guest of honor today, the artichoke. So this is actually the only edible thistle. We eat other things that are called artichoke. There's sunchokes, Jerusalem artichokes, but we eat the roots. So unless you're Eeyore, who only eats thistles and loves them very much, artichoke is our only kind of foray into the wonderful world of thistle eating. And until we seriously step up domestication for other thistles, it will stay that way for a while. Okay, next slide. And that brings us full circle to Cynar, because this is not only the unofficial birthday, as Danielle was saying earlier. This was also a great example of a bitters and how it can be used in cocktails, as well as how we can feature different botanicals by discussing this and others. Next slide.
Well, I gotta say, like, Cynar is so awesome. In particular because it's a really interesting clade in the Asteraceae family. So this is the daisy family. So dandelions going to be from here, lettuces are going to be from here. And it's really this one clade of just the genus that makes artichokes that has an enormous diversity of compounds that have been under domestication, where everything else, it's kind of like they're there, but they're in some like kind of low background level. So now getting back into like the chemistry, it's going to be a fun little wild ride for a second. Selena.
Yeah, so the chemistry of Cynar and artichoke. The bitterness of artichoke comes from this range of compounds, many different alkaloids, and some of the prominent bitter notes and compounds of artichoke are Cynarin, and Rachel's going to talk more about that in a moment. Chlorogenic acid, caffeic acid, and luteolin. And these compounds are found in multiple parts of the plant, including the roots and the leaves. And then maybe, Daniel, you can talk about what part of the plant in Cynarin is artichoke is sourced from.
Yeah, so for chinar, we just use artichoke leaf. And I think I'm glad that we're talking about it, because I think there's also often like a misconception of what the product is itself. And also people, I think they think that we have like artichoke heart that we like roast and ferment and like we make some sort of like mezcal out of it. They think it's like the base is actually some sort of artichoke, or that it might taste like artichoke in some way. But it's always good to make that distinction that the artichoke leaf itself, which is actually, I can show you this. We make these kits, these like little botanical kits, where we take the botanicals themselves, the dried botanicals. So we have like wormwood. We have, I think you can see them all here.
Mm-hmm.
If I can, it's backwards.
That's beautiful.
Yeah, so all of these, we use the regular botanicals, and then we also make tinctures out of each of them. So it gives you obviously the pre-tincture, pre-solvent and pre-solution, so you can smell it there like ahead of time, and then having that tincture and the ability to smell it and kind of like rub it on your hands and then taste it a little bit gives the the user the experience of what it actually is when you're finished with it.
We always have put bitters on our hands and smell them and then taste them.
Mm-hmm.
It warms
Where do
up.
where do you use those kits, Daniel? Are they for demonstration or education, or?
I mean, back in the day when we could like talk to people in person, it's funny, I literally would carry them around in my backpack all over the country, and like everywhere we would go, I would just like put little drops of tincture on people's hands and go through that tactile experience of smelling and tasting and all that.
That is so cool.
Yeah, that's really cool. Yeah, so back to the compound Cynarin. So while it's a bitter compound, a lot of times it's attributed to also being sweet. And this is because it's playing these sensory tricks to consumers. And so what it actually does, it inhibits the sweet perceiving taste buds. And then when it's washed away, and the next thing that we consume based on that contrast comes across as being sweet. So is this something all of you, Rachel, Ashley, and Daniel, have perceived or find?
Yeah, it actually reminds me of, because I was working on eggplants for my PhD, and there's these little turkey eggplants, Solanum torvum, same thing. And they're actually one of the other vegetables or fruits that are high in chlorogenic acid and these types of compounds that Cynarin is part of. And you would eat them, and then afterwards when you drink water, it's extremely sweet. And I never understood the chemical basis for that, but I'm betting it's similar to artichoke. That is so cool.
Yeah, and what's fascinating, it's not just the Cynarin, but it's really supposed to be a range of multiple compounds. So really that phytochemical synergy that's happening. So there's been some like old school studies back in the 70s that looked at extracts of artichoke leaves and then roots, and then also looked at the individual compounds, Cynarin and other in chlorogenic acid. And they did that sort of sensory testing, and they found out it was actually the whole botanical versus like those independent compounds that resulted in that sensory trick at the most extreme level. And so again, really thinking about botanicals, it's wonderful to think about the synergy of those compounds and really giving us that deliciousness and those flavor profiles. And in addition, these compounds have also extensively been researched for their antioxidant and anti-inflammatory attributes. And so where do these flavors actually come from, and why do they come to plants? And so there's really a series of different factors, and this is all very much linked to the environment. And so this is one reason why we at Shoots and Roots Bitters are so focused on really thinking about ecology and place-based bitters, is because these phytochemicals are very much upregulated in response to the ecosystem. And so there's sort of 4 environmental factors that are linked to a plant's phytochemical profile. One is its evolutionary history and ecology. So for example, artichokes are related to chrysanthemums, dahlias, and sunflowers. And so they have some similar phytochemical attributes. And they've all evolved in this very Mediterranean region. And this is reflected in their chemistry and flavor attributes. Also, these bitter compounds, most importantly, are very much linked to a plant's defense mechanisms. So unlike animals that are not rooted and can very much escape from different stressors such as sunlight, animals can go into the shade, or if they're attacked by a predator, they can run away. Plants have really had to evolve this very complex secondary metabolite defense system to protect themselves. And a lot of the compounds, a lot of the secondary metabolites that are really prized in flavor are actually secondary metabolite defense compounds in response to these different ecological stressors. So when we're thinking about capturing these different flavors from the environment, it's really important to understand the importance of a healthy ecosystem. And this really goes back to what Rachel was saying about the importance of really celebrating biodiversity and conservation. And when we're trying to understand flavors and sort of get these flavors, we need to understand really their ecological roots, and sort of a healthy ecosystem that celebrates planetary health very much is at the root of these flavors. Then there's also all sorts of other environmental factors, variations in season, in rain, that change the concentration of these compounds in a specific botanical, as well as farmer management practices. So there's a huge body of literature that shows that organic practices compared to conventional farming practices results in an upregulation of phenolic phytochemicals that are linked to the antioxidant and anti-inflammatory properties of plants, but also a lot of the bitter compounds. And so really understanding the environment is very critical in sourcing these phytochemicals.
Daniel, I wanted to give you a chance to chime in on what your perspective is on how people get the most beautiful flavors out of the plants, right? It's not like all artichoke would be the same for making an extract that would be delicious in a liqueur.
Yeah, I think, well, it's an interesting scenario because obviously all of our products they're done with completely different processes based on the fact that some are over 160 years old and some are, Cynarin, for example, is the youngest at 1952. So from a kind of a scientific standpoint, if you have something like Averna, for example, which was made in Sicily by monks in a time when science was not very close to them, I guess you would say, because they were in the middle of nowhere. It's a very simple process, and the maceration process is a very simple one-stage process with a very high-proof solvent versus Cynarin, which is done with a percolation process. And you have two very different ways to extract those things. So it's actually a really important part of the presentation that I always give is people have to really think about how each of these botanicals are handled. And if you look at the variables that you can apply to them, whether it be solvent strength, heat, time, all of those things will all add their own kind of like hand into it. And while going through the process, and I kind of challenge bartenders at times often, while going through the process of learning that and incorporating those flavors into your drinks, you should also go through those stages yourself. Try to go through each of them and apply them to whatever flavor you're doing. I think, when I first started bartending and making bitters, I did what every bartender does. You take a whole bunch of different things and you put it in high proof spirit and you let it sit for about a month, and then you have a really gross concoction of things that like doesn't make any sense and it's all muddled. But I think that this goes well beyond bitters and well beyond aperitif and digestivi. I think it can be applied in many different ways, but I think it's really, really fascinating the way that you've presented where things come from and where flavors come from, because I think that's the next step for bartenders, is to actually understand not just like, oh, this thing is from this country, but what is the landscape like? Where how was it created? And then at that point, we can actually go to the next level of teaching our customers what that is and how they can be more aware. And we can all work on this together.
Beautiful.
Yeah, that's beautiful. Yeah, so there's so many different processes that are really involved in the variation of secondary metabolites, really starting at the environment. And I know people so often think about and are so plugged into thinking about the terroir of certain products. such as wines. But I think we really need to expand that and really thinking about all botanicals and our foods more broadly. Yeah, so I really think it's sort of like the next step in having us reflect on these things. So Ashley momentarily will be talking about the variation that happens to these phytochemicals based on processing, and she's going to give a demo, using a sonicator to make these extractions and thinking about how phytochemical how phytochemical quality varies based on these different extraction processes. Next slide. So where are these compounds, where are these phytochemicals in plants themselves? And they're found in all different parts of the plant, the roots, the stems, the leaves, the flowers, the seeds. I think I'm missing some, the resins potentially. And so, and the level and the concentration very much varies depending on the specific species, as well as depending on the different compounds. Anything to add, Rachel and Ashley?
No, I think this segues into the next slide pretty well.
Over to you, Rachel.
All right, so this is like my favorite chemical pathway that makes this. So we're going to start with the basics, amino acids. So our DNA encodes, makes a code that gets transcribed and then into RNA and then translated into amino acid sequences, which are proteins. This is our basic building blocks of life. One of those amino acids is phenylalanine. You have lots of genes. We have these genes, plants have these genes that take those and break them down into different sort of derivative compounds. So you start with phenylalanine and you get cinnamic acid. Then you have other genes that you can turn off or you can turn on to either make lignin, like make wood out of that phenylalanine, or you can make something that's bitter or delicious and have a flavor and a function for the plant. So if a plant needs to be able to defend itself against herbivory, against some sort of caterpillar attacking it, it might, instead of making wood, to strengthen it physically, it might decide to make these defense molecules, these defense compounds. And what's really interesting about them is they have a couple of double bonds in them, where if you extract them in alcohol or you extract them in water, you're actually going to get different flavors out of them because the molecule is going to change. You're going to actually break those double bonds and add water. You're going to hydrolyze it, and that will change the taste. You'll get sort of like an oxidation taste. So what's really cool about these compounds is we know from other plants that they're extremely medicinally valuable. But oftentimes, for example, for Cynarin, we know that compound alone is, shut up, Hayes. Oh, I love you, but not right now. Okay, is anti-HIV. It's anti-cancer. It lowers cholesterol and does so much more. It protects your liver. It just in general protects your own DNA so that it's prevented from damage. And we know that from lab assays because we know that these are functionally important compounds, but there's not necessarily evidence that artichoke has been used for anti-HIV or anti-cancer in certain ways. We only have limited evidence from archaeological records of how it's been used. So lots of increasing potential. But I did want to mention that these will be different extracts in water versus ethanol. And so looking at if you're going to use traditional literature and try to like match some ancient recipe, making sure that you're matching the extraction method is really important here. Right?
Can I I'm so sorry. I got really caught up in all this and there's a few questions in here, sure, if that's okay. And it might be a little bit of backtracking, but these are really good questions. Also, shout out to Pando. Happy birthday. Just want to say that real quick. Okay. First question, is there a full list of phytochemicals and taste in your book?
There's no full list, but there is other sources that are really good for that.
Okay, and we should also mention that I believe this particular deck will be shared, and I think that people can see some of the information. Another question, American food and beverage skews much sweeter than many other cultures with stronger use of bitter ingredients. Have you found certain cultural traditions influence the consumption of bitters one way or the other?
Yeah, for sure. I think we all have anecdotes about that. I I used to do work in the Philippines where especially the older generation has an affinity for bitters. So we're going to get into the genetics in a minute of why we might have an affinity for bitter and how that is genetically encoded, as well as something that you learn through your environment interactions. Also in West Africa, there's a lot of bitter crops and bitters that people use daily. And so that environmental learning that bitterness is delicious and good for you, and you start to crave it, is there.
Yeah, I think there's a conditioning too when you grow up with an association either for a health or a functional benefit of a certain bitter vegetable. For instance, bitter melon in Asian cultures is attributed with beauty and health. And I've heard from people that were force-fed it as a child and grew to love it because they had this internal association that, okay, if I can endure this, it's going to make me stronger. But there's also, our taste change as we get older, and a lot of that has to do with, when we're just smaller, all of our taste buds are packed into this smaller area, and so there's literally a higher density of the taste buds that we have throughout our life as children, and so they're extremely sensitive to detecting bitter compounds or sweet compounds, anything at very low levels. So all of those times that a child is, sitting at the table being told to finish their vegetables, they're tasting a very different vegetable than the parents might be, and so that's something to keep in mind. Our tastes change across cultures, but also as we age. And
also, if we go through any trauma, like if your life experience, like if you've been in a car accident, that often changes like what you can smell and taste, and it can last with you for a short amount of time or a very long amount of time. So we're so sensitive to to this stuff.
I would also assume, like, culturally, access to, or maybe over excess of things like sugar or the having them in your culture would just become a part of your daily life in some way. And I feel like, especially in America, we have a ton of that, and it's one of those things that kids grow up just sipping on Coca-Cola all day long, and it's an interesting thing.
So while we have a lot of sugar, a lot of the times it's to mask something that's bitter, we're still receiving beneficial compounds from those bitter elements. Like if you've ever taken gymnema, which reduces your ability to perceive sweet, you can really easily find gymnema tea. We used to do workshops with this. You delete sweet perception temporarily for like half an hour, and chocolate is like disgustingly bitter, and maple syrup also, it's extremely bitter. And so we load so much sugar onto things that we actually don't think of them as bitter, but we're actually getting a lot of bitter compounds when you delete the sugar. I encourage everyone to look up gymnema and find some and try it in a tea. Right now. Yeah. You sort of gargle with it.
Is it with a J or a G?
With a G.
With a G.
GY.
GY. It's a lot of fun. You just like gargle with it as a tea. But some people, it can last up to 3 hours. So don't do this like before lunch.
So I shouldn't subject people to this when I'm doing trainings, or maybe we have lunch first and then
at the end of the trainings, and send them all home not able to eat or drink anything else with joy.
I'll just give them your info when they are upset about it. It's no problem.
I'm of the Jewish tribe, and it's really fun to do a gymnema dose and then drink like Manischewitz. It actually tastes like good wine.
Good to know for the holidays. Yeah.
A little trick to keep up your sleeve.
I've got one more question in here. Okay. Do growing practices, terroir, soil, different cultural herb cultivation methods affect the flavor of an herb produced in different regions? And does that come out in the bitters you make with it?
Yeah, and I want Selena to take this because it's a little tea question.
Definitely.
Yeah, absolutely. So there's a lot of different scientific evidence. So for each different type of botanical species, the ideal sort of growing conditions very much varies. And it also varies depending on which phytochemical or class of phytochemicals that you're targeting. And so it's extremely complex. And a lot of my research has looked at how tea really varies based on different agroclimatic practices or agroclimatic zones and management practices. And, we're looking at maybe over 200 different phytochemicals in tea that are imparting the different flavor attributes. And in some growing locations, certain phytochemicals are actually upregulated while others are downregulated or are present in lower concentrations. So it very much depends on like what you are targeting, but there's just so much variation depending on all of these different variables. And so sourcing is so important, and understanding the ecology of the place is so important.
And Ashley, you get to grow cacao varieties that actually you have like common garden experiments, so you can grow the same stock in like Brazil and in Indonesia and see what the different flavor profiles are. Do you want to go into that at all?
Flavor is incredibly complex, and there's a lot of factors that go into flavor. So we discussed some of the precursors of flavor that are determined by terroir, environment, climate over a particular year. But I think equally important, depending on the crop, can be post-harvest practices. And oftentimes those can even override genetic differences between flavor profiles. And when you're dealing with a fermented product that also has to go through drying and roasting stages, a lot of the genetic versus environment versus sourcing and post-harvest contributions to flavor get a bit obscured in the shuffle. So it's a very complicated question, and it changes from crop to crop.
Yeah, and from product to product, right? So it depends like what even like the alcohol base that you're using is, that could really, that you may be able to discern the difference, or you may not be able to discern the difference.
There's another question that actually came up that has to do with extraction methods and kind of the base for it. So regarding extraction methods, have you worked with glycerol for extraction, and can you speak to the difference between glycerol extraction as opposed to ethanol extraction?
Oh, have we worked with glycerol?
Rachel, I was missing that giant tub.
We had about 50 pounds of it in Rachel's bedroom. The thing is, don't mess with glycerol unless you've got a good clean counter space, because that is a sticky mess.
On its own, it's really like warm tasting. But yeah, everything is based on polarity. So, and then saturation. So glycerol, you're getting a polarity that is, I think it's a little less polar than water. So water would bring out more of the polar compounds.
Glycerol it's also great for making non-alcoholic extracts. I mean, it's a sugar alcohol, but if you want to avoid ethanol in a blend, even at low concentrations, glycerol is definitely the way to go. It changes the profile though, since there's so much more sweetness in glycerol than in an alcohol extraction. So you just have to compensate for that or account for it.
And I think like very broadly, like it really depends on the botanical and the phytochemicals you're extracting. Very broadly, it is like less efficient at extracting many classes of phytochemicals. But again, it very much depends on the specific botanicals.
Mm-hmm. Like for artichoke, I think the optimal, like based on my research, and Daniel, correct me, like it seems like optimally it's in water. Like artichoke as tea or as percolation is a really good method.
Yeah, we definitely use a hydroalcohol combination as opposed to, like I said, Averna is just straight alcohol. So I think that for what you're trying to extract, or the end flavor that you're trying to get, I think you're correct. But again, you know way more about this than I do.
So chlorogenic acid, which is like the blanket term for what includes like Cynarin, that is common in also like coffee. And there's like when coffee's gone bad, when it tastes oxidized, that's actually a flavor that a lot of people around the world really appreciate in coffee. But it's like where coffee has all of a sudden this like sweetness that's overpowering. And that is the like when there's those compounds, those double bonds have broken, and so you're getting that water converted molecule. I don't know. I just brought that up because I think that's what we're taking advantage of here when we're doing water extraction, and that's what's so cool is you're actually doing a chemical reaction in that extraction, not just amplifying certain compounds. But I think I have some more chemistry slides that we should just run through. Definitely wanted to mention here really quick that the wild thistle, which is Cynara cardunculus, was domesticated multiple times. It actually fertilized into a really wild variety, and it also became the globe artichoke and then cardoon, which is where the leaves are consumed, whereas in the globe artichoke, of course, we're consuming the entire flower head. And the genome was published in 2017, and so we can actually look and see in this domestication process where one of the first things that we do in domestication is we make things more delicious. So we can actually see what genes did we turn on and turn off, what did we upregulate, what did we downregulate when we made artichoke. So we can go to the next slide. And one of the things that's interesting is you've got two types of candidate bitter compounds in artichoke. You've got what we've been talking about, Cynarin, which are the chlorogenic acids or caffeoylquinic acids. And then you also have these lactones, sesquiterpene lactones. And a lot of the time people think that chlorogenic acid is what's bitter. But like Selena said, it plays a trick on you, right? It's got actually you're perceiving it as kind of sweet. There's no evidence that that's actually like the main bitter compound. It's the lactones. And we see this in other vegetables as well. So what you want to do is you want to actually reduce the lactones and keep all the good stuff, right? The things that have all these health benefits. But the lactones also may have some health benefits. So a sesquiterpene lactone, which is the extremely bitter part of artichoke, is that's the same type of compound as artemisinin, which is anti-malarial that you get from wormwood. That's one of the really beneficial things about wormwood. You'll find wormwood in products like Braulio and lots of other liqueurs out there. And actually, the Nobel Prize was given in 2015 for the person to Tu Yoyo, who discovered artemisinin in Artemisia. And that's in a variety of species. So wormwoods from China, from Europe, from California, those all have this wonderful sesquiterpene lactone in it. So those really bitter compounds, if you domesticate them away, you actually are going to still lose some of these potential health benefits. Can we go to and so one of the lactones in artichoke is specifically an anti-feedant. So this prevents your artichokes from looking like that if you're growing them. And so we actually reduced it heavily in the flower, but we kept it in the leaves so that your artichokes don't get eaten while you're growing them. So it's kind of cool that humans can actually say, I'm going to turn you off, but only in this part of the plant. You know, and the sesquiterpene lactones are stored not just in the entire leaf, but in the hairs on the leaf, which are like sort of your first line of defense if a bug's going to start to eat you. The leaves have hairs on them to hold in moisture. If you're in a Mediterranean climate, remember these are from the Mediterranean region. It's very dry in the summer, and so you don't want to just totally desiccate. So the hairs actually kind of protect you as a buffer so that you don't just evaporate away. We can go to the next slide. And here's where it gets really, really fun for me, is when we think of why do we taste bitter at all? This is because animals do. This is just because we always have. Primates can taste bitter, birds can taste bitter. This is a thing that's just common to animals. And so if that's the baseline, is sensitivity to bitter, to be able to lose the ability to taste bitter gives you an edge. You can eat things other animals don't want to eat. And so we actually lost the ability to taste bitter, some human populations, because we were competing with birds for food. So if a bird is going to eat all of your crop because you've domesticated out the bitterness, which is what happened in sorghum, then all of a sudden you have no food. So there's selection on people to be tolerant of very bitter sorghum because the birds leave it alone. And so we're actually seeing there's still genetic evidence of us interacting with, competing with birds all the time for foods. And you see this as a map of the landscape all throughout sub-Saharan Africa. You can go to the next slide. And if you want this paper, I can send it to you. I don't expect you to actually look at this table right now, but there's statistical evidence of it, and this came out last year.
Send it to me, Rachel.
I will. I just love this. I think that it's so fascinating to see how we've lost this. And so there's lots of bitter encoding genes. We can go to the next slide. There's lots of bitter encoding genes. The most famous one is TAS2R38, and I've genotyped myself, so you can like order primers and see which version you are. And I think if you do like 23andMe, it might tell you this information. But you can see like there's a couple of like versions of this gene. You can see which one you have and see how sensitive you are. And it actually is affiliated with like certain food preferences that you wouldn't expect. Butter and cured meat and beer. If you like those things, it depends on if you've knocked out this bitter sensitivity gene. In part, this is in a study in Italy. So a lot of these studies are like case studies from certain places in the world. A lot of them are studies on twins because they'll be like maybe subjected to different environments but have a common genetic trait. So yeah, I don't know. It's just a lot of fun to dig into. So everyone's different, and we just have to recognize that people are different for all of our different evolutionary trajectories.
Rachel, is this the same bitter gene as the PROP and PTC test for the same polymorphism, or is that a different receptor?
Ooh, this is one of the many receptors that test will tell you about. Yeah, so you can even buy PTC paper and put it on your tongue and see if you're sensitive to that compound. Okay, but it's surprisingly, there's no effect if you have this mutation on whether or not you like artichokes. So everyone likes artichokes, but if it affects whether you like butter, cured meat, and beer. Anyways, fun facts. So I'll flip it over to Ashley.
Okay, so now we're going to segue into the second half of the talk, which is a little bit more hands-on. We're going to talk a little bit about the techniques that we use to make bitters. And I'm assuming that we've got some people in the audience today that have dabbled in making their own bitters. So please feel free to populate the comment section with questions about your own creations, and we'll try to get to them all. Yeah, this is pretty much how we make bitters. We just line them up in glass vials, and no, this is not how we make bitters, but it is a really cool shot we got from the World Science Festival, so we're keeping it. Next slide, please. I'll go through the nitty-gritty of how we actually make bitters. Starting with, can we advance one, please? Thank you. So I'm going to take you through a few of the kind of key considerations that you should have on your mind as you're going through the process of making bitters. As we talked about in the beginning of the talk, we embrace this expansive definition of bitters, which is that these can be extracted in any different type of solvent that works. It can be a number of different plants that come together. Traditionally, we think of bitters as something that has a bittering agent and flavoring agents. So think about drinks that you've had that have maybe a kind of a sweetness to mask a bitterness, and that would be a perfect example of this. So when you're creating your own bitters, the sky is the limit, and you can really drive that ship wherever you find inspiration. But there's a few tools along the way that can help you do so. So the first question that we usually get asked is, how do I know that a plant is safe to use? And this is the criteria that we use. So we rely heavily on literature and a history of use. And believe it or not, this is also the same practice that the FDA uses to determine if something is safe. Is there a record of its consumption going back a long, long time? Then, if it hasn't left a trail of death and destruction, it's probably okay. So look for plants in the literature that have a use in food and medicine, and then look a little bit further and see how they were used. Was something a tea or a tisane? Was something a flavoring for a mead? If it was used in alcohol as a flavoring or a preservative thousands of years ago, then chances are it's safe to make an ethanol extract from. If it was used in a tea, then start with an aqueous extract and make a tea as well. Make sure that
I'm sorry, I'm gonna make a shameless plug for Google Scholar for this. I don't know if everyone uses Google Scholar, but that's what I love to use, and you can save articles that way, and you can get a lot of articles for free.
Yeah, there's so many tools out there, and we're happy to provide you guys lists and lists of databases that we've relied on for research and in writing the book. There's actually an appendix that has a few references you can look at as well. So another plug, another really important consideration is the quality of your ingredients. There's so many options right now. You can literally access plants from all over the world, from vendors of all sizes. So here, reputation is key. Make sure that you have a reliable source, because the plants are not the danger. It is potential for adulterants to enter the supply chain that is really what poses a threat to safety. And one example of this is this picture here, where you've got Japanese star anise on top and Chinese star anise on the bottom. And I couldn't tell them apart. I think there's a slight difference in the number of carpels that they have on the fruit, but there's a lot of variation as well. And yeah, I know I counted them all, and they all have 8. So I would be useless in telling them apart. They both contain anethol, which is the carminative property that gives them their flavor and an antispasmodic effect. However, the Japanese star anise also has levels of anisatin, which is it's a neurotoxin. It can cause seizures, and every year are cases of neurotoxicity incidents from people having adulterated supplies of star anise. So that's one example. Don't be too worried, because if you do due diligence, use good sources, there's nothing to be concerned about. Another consideration is where it's possible to source organic, or keep in consideration the part of the plant that you're using and if it might have had any exposure to pesticides or other pollutants in the environment. The last thing that you want to do is be extracting these into a very concentrated form. So another practice you could even consider is rinsing, doing the first rinse with ethanol and water and tossing that. Okay, next slide, please. Another consideration when choosing plants for your blend is sustainability. So again, there are numerous resources online that can help you in this quest, so you don't need to be starting from a place of knowing offhand what species in South Africa are threatened or endangered. You can go to the IUCN Red List, and they have lists for different regions as well as globally. And so, of course, we want to be conscientious consumers, and we don't want to put additional pressures on populations that are already under threat. Another consideration is the type of plant that you're dealing with. So, for instance, if it's an organ like Piper longan, these are little catkins from a relative of black pepper, and these are just fruits. They get plucked off of the spike, and it's sustainable. Plant will keep putting them out year after year. You don't have to worry about a thing. Sometimes, though, you might be sourcing whole plants. So here's an example from the Andes. This is a relative of gentian called Hercampuri, and each one is a tiny little plant. So you want to make sure, I'll hold it in front of my face for contrast. You want to make sure that in a case like this, you're really sourcing from a company that is conscientious about not over harvesting in a particular location. Believe it or not, this tiny little thing probably took a couple years to grow. So you want to make sure that they're not removed from the environment at a rate that's faster than they can actually regenerate themselves. Okay, next slide, please. And then certification is also important when looking at ingredients. So for instance, was the product fair trade? Are there farmer cooperatives, so you can ensure that more of the funds for that product actually make it back to farmer income and help to improve livelihoods in the areas where these products are harvested or farmed. So another step in picking your plant is, what is its story? What does that plant mean to you? oftentimes we'll grab what is available and known to be safe and kind of throw it into something together. And we're not even aware that we're recreating thousands of years of histories into something, and that every new ingredient that we add is meaningful, because you might be combining ingredients for the first time, and it might have complementarity that you didn't anticipate. And so think holistically about your blend and what each plant brings to the table. What story does it tell? What does it mean to you? Maybe it evokes some fond memory of your childhood or a travel experience or part of your heritage. But connecting to the plants in a way just beyond their existence as a spice on a shelf is really one of the most rewarding parts of making bitters. Next slide, please. And then finally, what is the sensory contribution of that plant to a blend? So there's a few different ways that you can look at the sensory components. So the first thing that we often think of is taste. In terms of the 5 basic senses, we've talked a little bit about bitterness and sweetness. We've talked a little bit about flavor modulation as well. So it may not be the case that a plant has a taste, but it may affect your taste of other foods or suppress or enhance them in different ways. Then there's aroma. This is probably the most important consideration for a bitter, because I don't know if we discussed this, but really when you are using a bitter, especially in a beverage, a carbonated water or a cocktail, what you're adding to that drink is aroma. A bitter is designed to sit on top of the beverage and to release all of these aromatic compounds. So you're breathing in a different drink than what you're tasting. And so their potency really comes through their aromatic properties. Once you tasted, the bitterness and the other flavoring agents come into effect too. But the very first perception you have of that bitter is before the glass even touches your lips. So that's a really important thing to key into. You want to make sure that those aroma active compounds are extracted in the solvent that you choose. I remember, what was it, Nigella sativa, we tried making some extracts from because that was this beautiful pungency, and then in an alcohol extract it was just completely bland and neutral. So make sure that you're actually able to extract the properties that you're targeting. And
that was interesting because flaxseed is so big in bitters.
I know.
Yeah.
Yeah, that was a surprise for sure. And then the stability issue is key as well. So you may have a strong extract, and then over time it's going to modulate, it's going to change. So continue to monitor it after you've made the blend. Mouthfeel is often overlooked in discussions on taste, but it's really important as well, to the extent that there's some controversies. We're not fully finished with the sense of taste. I would not be surprised if within our lifetimes there's a 6th or a 7th sense of taste proposed. I mean, we already lived through umami, and we're all the better for it, right?
There's kokumi now also.
Kokumi? Mm-hmm. What's kokumi?
Kokumi is similar to umami, and I would have to look up the Wikipedia to remember exactly what it is.
I'm already a fan.
Daniel, do you know?
I've never heard this, but now I'm looking it up.
I think it's another kind of savory.
Oh, neat.
But different. Yeah.
Yeah.
It is already growing. Yeah.
I included a penny on here. Why? Metallic is actually one of these kind of controversial, is it a mouthfeel or is it a taste sensations? And since we're all stuck at home, and I know you've got some pennies close at hand, here's an activity you could try with your kids or with your partners or yourself or your dog. File off, maybe not your dog, a little piece of the copper penny, and you've got nickel inside. So touch your tongue to the tip of the penny on the copper side, and then flip it around with the nickel exposed. Make sure it's clean first, because pocket change. And then touch the nickel, and you'll notice there's like a difference in the taste of the metals. So we're actually able in our tongues to perceive electric charge.
That's so cool.
So next slide, please. All right, so now we've picked our plants. We're pretty happy. We are ready to move forward with the extraction. So I'm going to talk a little bit about some of the key principles to keep in mind when you're making these extracts at home. surface area. This touches back on some comments that Daniel, you made earlier, and I love it. It was like, the first time you make a bitter, you just throw everything in a bottle, you shake it, you leave it on a back shelf, and you come back 2 months later, you taste it, and you're like, what? What was that? I think a lot of people start this way, and what we're going to demonstrate here is a different approach, and a little bit more targeted one, where you can modulate the tastes according to your own preferences. So there's a few different levers that you can play with in the extraction process. And Bailey agrees. One of those is surface area. So say you've got like a really high quality, valuable ingredient, you don't have a lot of it. You can increase its quantity just by grinding it up very fine. So your surface area in your blend doesn't have to be, how many ounces of a dry material you have. It's how much of it is coming into contact with your solvent. And here I can't emphasize enough, buy whole, grind fresh. Okay, get ready to love and lose a lot of coffee grinders and mills. You're going to go through all of them. The blades are just going to be a mess, but it's worth it. Yeah, there was that neon green one. I liked it so much. I think it was probably killed during that photo shoot.
Yeah.
It was those ume, those little shriveled dried plum prunus ume fruits. They were sticky.
Umeishu.
Mm-hmm.
Nice.
Yeah. So the same thing that Rachel was talking about, the principle of oxidation. If you buy spices that were pre-ground, by the time they get to your kitchen and your extraction, who knows how long they've been sitting exposed to air. And all of those volatile compounds, all of those terpenes, everything that you want to extract has already oxidized and probably either reduced, or it's just not of high quality anymore. So after you, what I'm showing here is actually not how we want to demonstrate it. What we suggest is, as Daniel showed you in his nifty little pocket kit, extract each one individually. So have like a little vial for everything that you want in your compound, and extract it. Swirl and resuspend so you can maintain that high surface area, because it will settle. So if you're extracting for a week, try and mix it up every day, but be careful not to extract the container. Glass, good. Tops of lids, bad. You don't want that making contact with alcohol. So store them upright, don't store them on their side, don't shake them, but just swirl them. Keep the alcohol just in contact with the glass. Filtration, this is a real trial and error situation for us. If you can't afford a home food grade centrifuge, which I'm guessing is probably most of us here,
I have a spin zone.
Yeah. We learned spin dryers worked pretty well too, in a nut bag.
Mm-hmm.
Right.
You can,
Rachel.
use a nut milk bag if you want to get like basically if you want to get all of the extract out. Use a nut milk bag, and put it in like a salad spinner, or in I'm not going to say what else we use.
Yeah. End of the day though, buy like a 6-pack of those little like knee-high stockings. You'll just dispose them at the end of the blend. You can squeeze it right through, and you're not going to clog nearly as many coffee filters in the process. Next slide, please. All right, we've already talked about this quite a bit, so I feel like you probably have been beaten over the head with this at this point, but I'm just going to reiterate. Different compounds have different polarities, so they're going to extract differently depending on your solvent. And like Rachel was saying earlier, alcohol and water, these are really primarily the two things that we use in bitters extraction. Water is a very highly polar solvent, and alcohol has some polarity, but it also has a nonpolar group. And so you can actually extract both polar and nonpolar compounds. So alcohol is great for organic compounds, things like your resins, your fatty esters, your fatty acids, esters, alkaloids. And so between the two of them, you can really cover a wide range of compounds, and you can capture the complexity in a botanical. Now, here's where we do something that's a little bit different. We like to do a high alcohol content ethanol extraction, and then an aqueous extraction, and then combine the two. Now, when we do this, you get this phenomenon called precipitation, aka what is that gunk in the bottom of my container? And this is a totally natural process. Remember, you extracted things that were soluble at a 80% ethanol rate, and then you just diluted it to 40% or 45%. And so everything that's not soluble at that concentration pops out and forms this beautiful clumpy cloud. It's a sign of authenticity. You're not using, artificial flavors or colorings. You've actually got plants in there. Of course, it's still shelf stable. It doesn't mean it's going bad. This stuff is in like 50% alcohol, so it's pretty much bulletproof. Other things to consider, other levers that you can play with, temperature and time. You can heat up your extractions to speed up the process. You can sample them at different time points to find out when you've got that optimal level before things get a little bit too bitter or too overpowered by a particular compound. And then pH is also a factor, and depending on, again, the chemistry of the molecules you're extracting, pH can play a big difference. So the picture you're looking at here is one of our favorite botanicals. This is Clitoria trinitea. Selena has been, I thought it was extracted already. No, okay. So it forms a beautiful blue, live demonstration, beautiful blue aqueous extract that ranges from almost a blue-green to a pink, depending on the acidity. So next slide, please. We'll have that demonstration in the background. Just let me know when you're ready, Selena. Then the next principle of extraction is another thing that's a little bit unique to us. And you can see right now, it's going into Selena's home ultrasonic bath. Everybody grab your home ultrasonic bath. If you don't have one, get one. They're not expensive. You can find one on eBay. They don't all have to look like they came out of a lab from the 80s. There's also some that are these nice little food grade ones, or just a home jewelry cleaner. But basically what you're doing here, okay, so we've had a little bit of a chemistry refresher. Now we're gonna go back to biology. Sorry, we're really raking you guys across the coals here, but remember that difference between plant cells and animal cells. Plants have a cell wall, and it is a fortress. So they've got a double layer that you have to penetrate to get into the cell, and then inside the cell, it's kind of like the container store. Everything is very neat and organized and packed in its own little compartment. So you've got these specialized organelles that are made to store all of these specialized metabolites. So your oils and your resins and your pigments and everything that the plant is ready to deploy on a moment's notice if it gets a signal that it needs to defend itself, etc., are right there in these cute little vacuoles. So we come in with our sonicator and use sound waves to just break them apart. This is that picture at the beginning. That's literally what this is doing. You're using sound vibration to disrupt the cell on a molecular level, which is something that as good as your Krups grinder is, you're never going to get it to the level that you can get with a sonicator. So what this does, Rachel?
Oh, my sister, I was sonicating something, like I was making us a cocktail when she was coming over and hanging out, and she started yelling at me. We fight all the time. She's like, "You need to wear ear protection. You're hurting all of us." And I'm like, "No, I can't hear that it's bad." And it actually can. It is good to don't run it in a room that you're spending time in, because it actually has ultrasonic waves that are bad for your hearing, and you might not hear it. Your pet might get really bothered by it, or over time it might damage your hearing. So just word of warning. with an ultrasonicator that it's loud and you can't even perceive it.
And it might be a fun party trick to feel the vibrations in the water, but don't keep your finger in there too long either. You don't want to sonicate your finger cells. Next slide, please. Okay, so now I want to talk a little bit about building your blend. You have picked your plants, you've created your optimized extraction for each one, and now you're ready to recombine them into this magical alchemy that will be your bitter blend, and it will be totally different than the sum of its parts. So how do we make sure that what you create is a total masterpiece? So we like to go flavor by flavor, each extract, and really become familiar with what it can offer to the blend. So like Daniel was saying, this is a good time to use the back of your hand, taste each and smell each in small quantities. Because remember, you're trying to taste the extract and not just the alcohol. So if you take spoonfuls of it, it's not going to achieve the same effect. So is it pungent? Is it overpowering? Should it be present in small or large quantities? These are the types of questions you should ask at this stage. As you combine them together and taste them in combination, you want to achieve a kind of complexity or a completeness of a blend. So something that has, we aim for 3 different phases of taste perception. Something kind of sharp and upfront, an initial perception, and then the body of the bitter. So what you get right after that initial taste, and then a linger. You want a little bit of a flavor trail. So to really fully characterize the bitter, try to touch each of these categories, and then there's combining it with the drink that you're using it in, and you could try a few different things. So you could try carbonated water, a cocktail, and just straight water for this next part. How many drops of your bitters does it take for you to be able to smell it over the rest of the blend? How many drops does it take for you to be able to taste it? When is it overkill? So all of these types of questions will really help you not only create, but perfect and then administer your bitter as well. Do you guys have anything to add to that? Rachel, Selena, Daniel? So a couple of helpful hints that we've learned from trial and error over the years. Do this at home and don't plan to drive afterwards. You may not be consuming a lot of alcohol, but it is very high proof alcohol, and you're consuming a lot of very potent extractives. So you're not always sure how those are going to hit you. Better to do it at home.
When we were designing some drinks very early on, we all were trying to make it was a bitters for if you're going to trek along the Silk Road and you need to be able to sleep pretty well. We called it Sherpa's nightcap. And we all got up from the table after figuring out the blend that we liked, and we realized we couldn't walk. None of us, we were kind of half paralyzed temporarily. Just a couple weeks ago, we were designing a tonic, and realized that having 10 glasses of something instead of 1 glass of something, that we were pretty messed up. So it's really easy to accidentally drink a volume of the plants that you're not normally going to.
Yeah, those are great points. And then the other thing I wanted to add is going back to what Ashley was talking about before in terms of telling the story. And so this is sort of like the sensory aspects of building your blend, but keep in mind the plants that you're selecting again are telling that story. So is it a story of place? Like, what is that story you're telling? So kind of thinking about this formulation coupled with that telling of a story.
We've always really enjoyed making these bitters together because everybody brings a different perspective to the table. We've talked a little bit about the diversity of bitter genes and the diversity of our olfaction. So everyone will have a different perception of a blend. And if you want to have something that is going to be a more universal crowd pleaser, invite, the picky friends, the friend that'll eat anything, the cook, people that have different nuances in their experiences of food. And even after you extract and filter, make sure you taste it regularly. Blends will continue to kind of extract as they sit on the shelf, and things will settle. So it will change over time, and sometimes this can be an improvement, and sometimes it's better consumed fresh. So only you'll be able to know that about your blend. And last but definitely not least, keep good notes, label everything. If you stumble on the perfect formula, you're going to want to be able to go back and recreate that at every step of the way. So next slide, please. And I wanted to offer forward a discount that our publishers have provided for the participants in this workshop. We've talked a little bit about our book, Botany at the Bar. This was released in 2019 through Roost Press, and it contains a lot of the information that we've talked about today. It features over 200 plants in nearly 80 different recipes. And so whether it's bitters or cocktails or even non-alcoholic drinks you're interested in, but you just want a kind of, the Clitoria extract is done. So I'll leave that on the website.
I know. I sort of messed up the demo because I was supposed to have like the version that I didn't sonicate compared to the version that was sonicated. And now you're like, well, what's the benefit of the sonicator? So apologies, totally messed up the demonstration. But this is after 15 minutes in the sonicator without any heat added. And you can also add heat. And this was just in water. So this is a water extraction. And so, yeah, I totally messed up the demo. Apologies. I should have done a comparison of like, what does this look like if I didn't actually put it in the sonicator?
This is like the perfect example of only vary one variable at a time. That is so great, Selena. Glad you guys got to do that demo.
Sorry to distract Ashley.
No, that was perfect timing. Yeah, with that, I think we would like to turn it over for any other questions.
There are a couple more questions that I'll put up here.
Oh, but first a dad joke. Where did the artichoke go to have a couple drinks?
I don't know.
The salad bar.
That's good.
That was cute. Thank you so much. Thanks for sticking with us. I really appreciate that we're able to do this workshop together.
I think honestly, I think this is one of the, this is fascinating for everyone. I think, especially bartenders, anything that's flavor oriented, of course, but with such a boom in Amari and bitters and things of that nature in the past few years. Even, I mean, myself, my entire job is literally going around talking to people about stuff like this. It's fascinating to see the science behind it and explained in a way that's easily digestible. And I think that's one of the most important things. Finding a way to speak to people that have no scientific background whatsoever, and relaying all this information can be really heavy for people that don't understand it. And I think you've all done such a really amazing job of making it not only fun, but like easy to learn. And I've taken a lot of notes for myself for how I do my presentations and things that I'll say too. So I greatly appreciate it. And I'm sure everybody else does who's tuned in. And I'm going to just ask a couple of the last questions, if that's okay. So one question about extraction, is fat extraction common in bitters production?
I'm going to pass it to Ashley because she deals with fat extraction with chocolate, thinking about chocolate.
Well, yeah, that came to mind right away when I saw that question. Yeah, I think that's an important step if you're using anything that has a lot of vegetable fat in it. And whatever the method for that fat extraction will totally depend on your resources. You could do a kind of a press, but that takes a lot of pressure. We've just extracted everything and then kind of siphoned off the cocoa butter after the cacao beans that we were extracting separated and started to congeal. Fat is definitely problematic. We aren't. Yeah, I don't have anything incredibly sophisticated to say about a defatting process. Just, you want to get it out of there because it will go rancid.
But I've been really impressed with seeing how bartenders use oils to float on top of cocktails, and I'm really excited to drink more of those.
Yeah.
Yeah, and it's cool because when you're using a fat to extract the botanicals, sometimes you're getting a lot more of like sometimes some of the aroma compounds that you don't capture necessarily if you do an alcohol extraction. So I think it's an exciting way to get a new range of compounds that we don't necessarily focus on.
All right. Another one. Many Amari have secret recipes, but having a strong sense of what is in a spirit can be very helpful when creating cocktails. Sadly, I'm not a super taster. Sorry, Jared, not a super taster, me neither. And I don't own a gas chromatograph. Did I say that right? Sorry. It's the first time saying that out loud. And mass spectrometer. Shame on me, I know. Are there more readily available tools, resources you'd suggest to help determine ingredients?
Okay, so you're wanting to hack, you're trying to reverse engineer a secret Amaro. I've been trying that for a little while. I've been trying to use ancient DNA techniques on it, and it's really, really, really hard. That's probably why we haven't hacked all of those yet. Gosh, where do you go from there? I don't know, Daniel.
I don't know all the recipes for all the things that we have. I've been fortunate enough to visit some of the places and kind of like search through the sacks that are in the corner and try to identify the botanicals just from visual, take a photo and then later ask somebody who's more familiar. Chinar is a good example of this. We know that there's 13 total ingredients, one of which being artichoke leaf. After tasting that and many other things many, many times, especially because the scope of the things that I taste are much more narrow than I'm sure what you taste, I'm able to, I could tell you what I think is in it, but there's absolutely no way that I'm going to figure that out. I mean, it's so crazy because they're so intertwined.
Yeah, and I think just kind of celebrating that culture of secrecy is part of how a lot of cocktail bitters have their history. And so I think first we were very plugged in on trying to figure out what a lot of these products have, and then kind of coming to the terms, just kind of let's celebrate that culture of secrecy for our own bitters, for Shoots and Roots. The products we've created, we've been very transparent in providing what the botanicals are. So really, trying to be very transparent and not necessarily paying ode to that culture. But I think there is something also to honor in that culture of secrecy as well. So I think, I think it's hard to, even if you have all of the tools to see what's in a recipe, the reason it's secret is for a reason. So just kind of honoring that.
One of the things that really impresses me about flavorists is that they don't use a GCMS right away. They don't use an LCMS right away. They use their nose. And one of the beautiful things about plants is they're all related to each other. And there's a lot of redundancy in their chemistry. So we were talking about compounds that you find in coffee, in artichoke, in eggplant, in dandelion. And so if you were to swap out one for the other, when you're trying to recreate something, you might get lucky and land on the note that you're looking for. And so chemically, you might end up with something that's very similar, even though you're using a different species.
And I would, this is kind of what I always tell people when they ask me, what's the recipe? And because they ask me all the time. And aside from maybe Averna, because it's the most simple process of anything possible, there's so many different layers to it. I mean, Campari has, if you were to go through it, it has maceration, it has just straight infusion, there's distillation involved, there's like many layers to it, and you would need to know at what point in time, how it was done, the length of time, the temperature of those things in order to try to recreate it. And there is something, and Selena mentioned, there is something really amazing about the fact that the consistency of that flavor has lasted since 1860. And to me, that's kind of an amazing thing. And when referring to the product or other products that are similar to it, I'm all for people creating their own things that are similar to what we have. I have no problem with that whatsoever. But, you're going to know which one is which. It is very, very obvious because at that point in time, no one can recreate it. It doesn't matter how you, how much research you do, tasting or whatever. You need to know really specific things about it, which you beautifully explained in this presentation.
There's one bioethics thing that kind of irks me about the secrecy stuff, I'll be honest. And that's that when people say that they use wild plants from the Dolomite Mountains or from the Alps or from, and then I'm like, well, who's making sure that those plants are not being over-harvested? And why are these companies not showing the good that they're doing about replanting? We see like with a lot of different spirits that rely on wild herbs that like that's a chance to promote conservation, and they're missing an opportunity. And I think right now we're seeing the state change where people want to see how people are being good stewards of the environment and practicing sustainable practices. So I would love to see a little bit more transparency on sourcing and on stewardship.
I think
bartenders, you push for this. You 100%. Change policy.
And I was just going to say that I think especially in agave spirits in general, obviously this is getting like a little off topic from my perspective, but I think agave spirits are the best example of this because there was such a big community around wildly harvested things that take multiple decades to grow. And at that point in time, you really have to understand that if that is the fascination you have with this thing that takes, and you mentioned it, Ashley, with the plant that you had that could have taken a couple of years to grow. Well, what happens? Who's replanting that? And is that something that we even want to promote in general?
Yeah, exactly. And agave is such a great example of that challenge because it's not only the existence of that plant, it's also its role as a pollinator in that ecosystem and the genes that it may have that maybe haven't even been, we don't even know the benefits that those genes may have. But now when we're entering an era where climates are rapidly changing, plants are having to adapt because, as Rachel said in the very beginning, they can't run away. They're stuck where they are. So all of that diversity is important. And each little component of that ecosystem, whether, maybe it doesn't make the best mezcal, but maybe it's contributing genes that will be critical for the survival of agave in that valley for the next 100 years. So you never know what you're disrupting.
Well, with plants, right? I mean, and this could be bees, it could be flies, it could be whatever it is, and it affects. It is a domino effect in the environment. Yeah.
I see there's a question about fresh versus dried flower extracts, and I wanted to make sure that we address that.
Yeah.
I think you're going to get totally different chemistry from either, and it just depends on what you want. Like, for example, for orange blossoms, if you want like neroli, you want fresh. You're just not going to get the same beautiful quality if you're doing an infusion with them dried. With rose petals, it's probably either, but you need to harvest them in the morning because that's when they're releasing all of their aromas. So I don't know. Just wanted to mention this.
Love that.
Ashley, yeah. Daniel, you have to be careful also about releasing wound response phenolics. If the material is too fresh, you're going to get that kind of grassy aroma in your extraction. You're also making more work for yourself since fresh material has a lot of water weight. The equivalent weight in dried material is going to be an order of magnitude more volume for you to extract. So it's, if you have access to both sources, or if you're able to, sun dry it or air dry it or put it in a plant press or something before you extract it, you'll probably save yourself some time and really target compounds that are inside of the plant and rather than wound response.
So an interesting question here, I guess, when we were talking about harvesting wild plants, and then obviously now we're talking about fresh versus dried. For example, we did some foraging in the Dolomites because of Braulio, and we were going around and collecting juniper, and juniper is a really interesting globule that when you taste it fresh is a very, very completely different thing. I mean, it is sweet, it is like a fruit, it's amazing, whereas the effect that we have in Braulio and that piney aroma and all that smell comes from the dried version of it. So is there something to, and I guess foraging, I guess, is the main point here. Is there something to foraging that you could figure that out ahead of time? You could look at something and say, oh, this is something that I should pick now, or I should pick later. Or are there things to that plant that maybe you're like, this would be better dried? Or is there anything like that visually speaking?
I go with monoterpenes. Like, I definitely prefer to extract those compounds that are from like your non-flowering plants, so pines, firs, sequoia here in California, and juniper. Anything that doesn't make a flower, I always think of as better fresh. It's interesting that juniper is like the one exception where it has a more desirable flavor profile dry. And I'll also say that goes for some of the early divergent plants, like in the Lauraceae family. So fresh bay leaves are really disgusting to eat. I actually start coughing a lot with them. Like there's some nasty compounds in there. But then dry, they're delicious. California Bay is becoming really popular. And that's also sort of the same thing. So I don't know, if you have a tree of life in front of you, if it's basil, generally go dry or go fresh, or nope, never mind. There's no rules. Throw it all out the window. But oh gosh, you can always try a little bit fresh, and then decide.
If you're also trying to target a functional aspect of that plant, then timing really matters. So for instance, like linden tree, you want to harvest the flowers right as they sort of open in early spring. And then they also have a different aroma at that point too, and a different flavor. Ginkgo biloba, well, we don't recommend extracting ginkgo because it has a lot of other kind of nasty gingolic acids that are sort of, they can be toxic and allergenic. So go with the standardized extract on that. But when they process for the standardized extract, they do it when the leaves are turning from green to yellow. So right at that kind of seasonal change. So if you can kind of harmonize with the plant's chemistry, if you know what you're going after, it can be a big benefit.
These are questions like you're doing hardcore research when you're making your own plant extracts, and like you're getting into really, really cool biology and chemistry and geography, biogeography. So I'm glad that you're geeking out to that, and I encourage you all to do that more, and definitely get in touch if you have follow-up questions. shootsandrootsbitters@gmail.com is our email address. You can also find us at our at Ashes at UC Davis. I'm at UC Santa Cruz, and Selena is at Montana State University in Bozeman. So like we definitely want to work with people to help you get the most out of exploring biodiversity in a safe way, and in a way that's good for the planet. So
I love that.
Send us your creations. Let us know how everything turns out. We're always curious to see people innovating.
There is one question about a cocktail creation here with a sonicator. Can you use a sonicator to mix a cocktail if you just set the mixing tin in the sonicator?
Don't use metal, use glass. Yes, you can. If you're putting citrus in, you're going to be mixing your acids and oils more, so be careful with that. Oh, I can't think of a reason why you'd have to have the whole cocktail in. I guess if you're trying to like on the fly use like your spirit to be the vehicle for your extraction. But why not? Yeah.
I guess maybe
cool.
maybe the question would be more like, can you actually, instead of shaking the cocktail and emulsifying everything through that? No. Okay. Okay.
There's this tiki bar in Silver Lake that it's like two old men that have been running the joint forever, and they don't want to shake cocktails anymore. Tiki tea, you know it? Yep. And they just put it in that like milkshake mixer machine. It's brilliant.
That is actually a very common utility in bars like that, in tropical drinks. The Hamilton mixer, if you look back, was one of the first things ever used in as far as equipment in bars like that. And if you go to some old, if you're near San Francisco, the the hotel that's on Union Square, I believe it's a Westin, it used to have this really old cocktail bar in it, and they have all the photos from it. And if you look at it, it has a photo from down the line, and every station had a Hamilton mixer at it.
Wow.
And it was a very expensive, large hotel build, so it was like very important to them.
That's cool.
Anyway,
That's cool.
now we're getting real crazy.
Well, we need to be learning from more bartenders and people in the industry. You're driving everything forward, and we wouldn't know how to make anything delicious if it wasn't for your patience working with us over the years. So we're really grateful.
Mm-hmm.
I'm also very grateful to bartenders because they use all of our products to make creations, and then I get to promote them along the way, which is super fun. So
Daniel, we're opening a bar.
let's do
We
it.
need to get you out here,
All
Quixote
right.
and
I'm
Livermore.
Well, I'll tell you what, I'm not far away. I'm down in LA, so I'll come up.
Perfect.
Okay. All right. Well, thank you so much. We lost Selena. She had to run, but Rachel and Ashley, thank you so much for your time. Everybody, if you haven't, go grab a copy of the book, Botany at the Bar. It's at roostbooks.com.
And go grab some of this.
Ooh, some Cynarin 70. We got them both. I love
33 and 70.
Amazing.
I've been mixing this with gin and sherry to make a really nice aperitif, and it's mind blowing. Now I'm going to try with the Braulio because I didn't realize juniper was in that.
Mm-hmm.
So it'll be fun. Thank you.
All right. Well, thank you so much, everyone. Thanks for joining. So glad it's super fun. I'm going to reach out to you all. Hopefully we can do a seminar together in the future. That'll be a lot of fun.
Would love that. Thank you,
Definitely.
Daniel.
Cool.
Good
Thank
to
you,
see
everyone.
Ashley.
Thanks for sticking around,
Thanks.
guys.